Congratulations, you have just found the ultimate guide to building powerful, flexible, and RESTful APIs in Node.js with Express. If you made it here, you are probably curious about API development, or you have already started but want to level up your skills. Either way, you are in the
Yes!
perfect place. In this course, we didn't just scratch the surface. Oh no. We dived deep from setting up a clean folder structure, understanding routes, controllers, and middleware to implementing a real-world features like validation, error handling, and the magic of hypermedia links. That makes APIs self-descriptive and future-proof. And guess what? Everything taught step by step using modern best practices with modular export and import structures. I kept it beginner friendly and fun, but we also built professional scalable APIs you can actually use in real projects. So whether it is for a portfolio piece, a client project, or your dream SaaS product, this course sets you up for the success. So if you are ready to go from I'm still figuring out APIs to I can build APIs with confidence, you are in for a treat. Watch this course from the start to finish, and I promise you, you won't miss a single best practice or coding tip. Don't skip a step because every chapter adds another skill to your developer toolkit. Let's make your API game unstoppable. So grab your coffee, open up VS Code, and let's crush this together. And don't miss out, this course is everything you need to become a solid API developer. So let's go. Now let's jump straight into setting up our environment so we can start building our RESTful API with Node.js and Express. Go along step by step and you will have everything ready in no time. So first things first is we need to install Node.js, and you can go and visit nodejs.org in your browser, and then go and download the LTS version in your machine. And after downloading it, install it like any other software on your computer. It is super straightforward. Just click next until it is done. Now, to verify that Node is installed on your machine, you can open up any terminal or built-in terminal on your machine. I'll be usually using Visual Studio Code as that's my preferred editor, and it have built-in terminal. So you can go and write node dash v, and then you can see the current version installed in your machine. And that will tell you that you have successfully installed Node. Now, next thing we want to do is basically set up our project folder, and I already created a folder in my machine called RESTful API Node Express. You can create a folder and name it anything you want, and then go ahead and open your folder in your favorite editor. So I'm using again VS Code, but feel free again to use any editor you like. Now, what you will do is go and open your terminal, and then make sure you are pointing to your folder that you'll be building your projects inside. Then what we'll do is we'll run a command called npm init. And then you'll be asked actually few questions here. Okay, so let's go that running, let that run. So you can here you can name your package anything you want. I'll just call it my API. And everything else I'll just give to the default. So just keep hitting enter until it's all finished. And I'll say yes, and we are done. Okay, so when you are done, you'll see a new file popping up on your left, okay, of your editor, and that will be called package.json. And this file basically keeps track of your project metadata and dependencies as well. Okay, and as you can see here, the name I created and everything here is default values I left. Now, when we are done with this, next thing we want to do is to install Express that will help us create our server. Okay, so you go again to your terminal, make sure you're pointed to your correct folder, then run npm install Express. And that's what we'll do basically. This command will don't express for us and add it to our project dependencies, okay? And you will notice it gets listed in the package.json file automatically for us, okay? So at this point of time, this is the current version we have installed. Now, next thing I want to do basically is creating a server. So we'll start by adding a new file. I'll call it app.js, but feel free to call this anything you like. And first thing we want to do is actually import Express that we installed from Express. And next thing I want to do is create an instance of this Express. So I'll create a new variable const app equal Express. Great. Now we create an instance. Next thing is we want to have is a port, okay? On our local machine, which port this will be running. So I'll define a new variable, call it port, okay? And what I will do, I will say that's equal to process dot in dot whatever variable you call. So this one later, for example, if you want to have a configuration file, and that configuration file have different ports, for example, different environments. For your local is different, for SRT is different, for dev is different, for production is different. So I didn't create it yet, so I'll have to handle that. So I'll say if this one doesn't exist, then use port 4000. Okay. Now next thing I want to do basically is just create a simple route that will point into our slash route. So the way we can do it is we access our instance of the server, so app that we created dot, and we use the get method for now. And I'll be pointing to this route only slash argument. It is an arrow function that takes in by default two arguments, your request and then your response. Okay, for now we will not do anything. All what we will do is just send something with our response, response.send, and we'll just display a message at the moment. So we say welcome to my API server. Nice. Now next thing we want to do is actually run the server and listen to it so we can access this route. So the way we can do it is using app.listen, and this app.listen, again, you pass on the port you are using. So I'll pass the variable I created, and the second argument is a function that will run while listening. So for now I'll just do again a console log. I'll say running server on port, and actually I should fix this first, and because I will use variables, so I'll use the backticks and do this, then display the port number I am using. Great. Now we have basically a basic server running, and we can go to our terminal and run it. So the way you can do it, again, make sure you are in your folder and write node, then space, then the file you created from this app.js. So as I do that, you can see here I have first an error coming up, and that's basically I'm using a module base, and I have to tell my app that I'm doing that. So I have to go back to my package.json, and I will add a property called type, and I will say that's type of module. Nice. Now we go ahead to our terminal and try to run that again. And you can see we have a console log here. So we are seeing running server on port 4000. And I'll go to my browser and run localhost 4000. So whatever port I'm using. And you can see, I can see that message also display on my browser as well. So a recap for what you have done up to now in this chapter. So we download and installed Node.js in our machine. Then we initialized our package.json using npm init. Then after that we installed Express, okay, in our project, and then we just build a very simple server that listens to the port 4000, okay, and handles a get request for us. Great. Before we jump into building our RESTful API, let's break down this REST thing in the simplest way possible. So this is a spoiler alert for you. It's just a fancy set of rules to help server and clients talk to each other without things getting really weird. So REST stands for Representational State Transfer. Sounds like something out of science fiction movie, right? But nope, it's just a system that Roy Fielding dreamed up back in 2000 to make the web less chaotic. So think of it like a house of rules for a shared kitchen. Everyone knows what to do and there is less mess. Now, the big three REST constraints are: the first one is the client server relationship. This is basic. The client, you and your browser, asks a question. Hey server, what is 2 plus 2? Then the server answer, which is the big powerful machine, replies to you, it is 4, you're welcome. That is it. Requests go one way, answers comes back. No drama, no side plots. The second thing is the stateless server. Servers are forgetful. They don't remember what you ate for your breakfast. Every time the client asks something, they have to send everything the server needs to know how to respond. Why? Because if one server forgets, another server can easily take over and answer without needing a memory joke. Think of it like, dealing with a customer service chatbot. You start from scratch every time, but at least it always work-ish. Okay, then the third thing is caching. So imagine asking the same question over and over, like, what is my name? What is my name? What is my name? The server gets annoyed. Instead, REST says, if the data isn't going to change, your name is Bob, cache it. That's why the client can remember the answer for a while instead of asking every 5 seconds. And that is REST basically. It's just a set of rules of engagement to keep your APIs efficient, scalable, and a little less dramatic. Now, let's see how to actually build one. Alright, let's get up with the right tools before diving into building our RESTful API. And here is what we are going to do. We will set up ESLint, so to ensure our code is clean and follows the best practices. Then we will add NodeMan, which automatically restarts our app when the file changes. So let's do the first thing. So I'll go and stop my server, and then I'll install, so npm install ESLint, and I'll do dash dash save dash dev because I want to install this one as a div dependency. And what that means to you is that when you install a div dependency, when you run your app in production and it runs as npm install, it will not install this package because it's not needed for production. So I'll go and hit save, and same time I'll open my package.json so you can see that one coming up. And there we go, you can see ESLint's been installed and it was added as div dependency, not same as Express as we added as an actual dependency that we need also in production as well. Now, next thing we want to do is basically install ESLint globally, and we'll use it locally in our npm script. So what I will do, I'll go here and do npx ESLint dash dash init. So this one will help me to initialize my ESLint config. I'll go ahead enter. And you can see here it says I need to install some other packages. I'll say yes, go ahead and do that. Now next thing it will ask you is some questions. So it says, would you like to use ESLint to check syntax only or to check syntax and find problems? So I'll go with the second option. And the second thing it will ask you is what type of modules that you use. Okay, we'll be using import and export or require and export. As you can see in the first part of this video, this course, I'm using modules, so I will go with that as option. The next thing it will ask you is which framework does your project using. Okay, so I'm not going with any framework. I'm sticking with JavaScript for today's tutorial because more about building backend, so building APIs, so I don't need any front end. So I say none of these. Then does it say ask a question, does your project using TypeScript? Well, I'm keeping this one simple for today, so I'm saying no. I'll just stick with normal JavaScript. Then next thing it will ask is where does your code run? Actually my code in the browser, so I will select browser. And then next things we'll ask you is that would you like to install them now? So we need a few other packages to be installed. So I'll say yes, go ahead and install them. And I'm using npm. So it will go ahead and install them. You see them popping up as well here when it is done. Great. And you can see that all of them have been added as actually a div dependencies and not a dependency, okay? Because they're all needed only for the development part. That is completed. Now, we have our package initialized. You can see here we have a new file which showed up here, which is the ESLint config, okay? And at the moment, I will not do anything to it. I'll just leave it as it is. Now, next thing I want to do is add a new script so I can run my lint command. So I'll go here and add a new script. I'll call it lint. And that script, what will do for me is it will run ESLint. And that ESLint will run on all the files we have at the moment on our project, which at the moment is just app.js, okay? To run and check the code if it's all good. Now we can go to our terminal and run it. So I say npm run and the script name, which is lint. So lint, and let's see what it will find for us. So see, you can see it find one problem. It says process is not defined, okay? And if you go back to our app.js, that is the one right here. Now, this is a very special error. Why? Because it's not like a missing variable or something, okay? The process here, it says, is not defined because ESLint does not recognize that this process as a global variable by default. So this is common when you are working with Node.js. To fix it, all you need to do is let ESLint know that your code is running in Node.js environment. Okay, now to fix this problem, we just have to go and open eslint.config.js that got generated. And we need to add basically a few things, okay? So we can tell it that we are running using Node.js. I'll just paste some code where I just add this bit right there, okay? And to explain you this, basically, the globals.node is from the globals package added supports for Node.js specific global variables like module or require and process. Okay. Then global.browser ensures browser specific global remain intact if you are working in mixed environments like client and server. Okay. And the file pattern, which was already there, that will basically ensure that the configuration applies to all JavaScript and TypeScript files as well. Now let's go and save this and run our command and test it. Now you can see it's all working and happy, means our code is perfect and there are no problems with it. Now next thing we want to do basically is to install Node.man, okay? And the way we can do that also, it is very simple and easy. First we go to our terminal, run the command npm install Node.man. And this will also be a div dependency. Save, because we only need it when we are actually doing the development. So I'll click enter, and that should go ahead and add the Node.man for me in my list as well. So you can see it right there. Now next thing after that one is done. What we have to do is add again a script that will help us to run our project from this script. You remember before we used to do node space app.js? Now we'll do it differently. So I'll create a script, I'll call it start, and then that's what it will do. Node.man space app.js. Simple as that. Now this is done. We can add actually some configuration if you want to. For Node.man, I'll go and add a new file. I'll call it nodeman.js, and I'll paste some code here as well. Okay. Oops, that shouldn't be .js, that should be .json. Let me fix that. And basically this one is just some configuration, for example, saying that I want the script to run after 1 second. The environment will be to port 4000 and the environment will be development. And I'm saying, okay, watch for me the app.js changes. Okay. Now we can go back to our app, or actually package.json, and we'll go to our terminal and we'll run the new script. So npm space start. Hit that enter, and you can see the script is running right there, node app.js. You can see I'm restarting, it's watching for app.js, and you can see the service starting successfully, and I can see my log of my console, which is right there. Okay, now if I go at a small change, I'll just remove server and hit enter. You'll see that after 1 second, my server runs again and pick up the new changes. There are no problems. So it's running again my server on the port 4000. Now, as a quick recap for this chapter, again, what we have done is we first installed ESLint, which keeps our code clean and error-free. And then we installed Node.js and created a script with it as well that save us time by automatically restarting the server on any change we do. And there you go, you're all set up. Next thing we'll dive actually into building the actual RESTful API. Now that we have our basic site up and running, it is time to start building our RESTful API. Now we are going to set up our first get route using Express. By the end of this chapter, you will know how to create routes, organize them into reusable routers, and test your API like a pro. So let's dive into it. Now, first thing, let's check out what we already have in our project. So if you look at the app.js, we have got the basics. We imported Express, we created an instance of the server, we set up a port from our environment variable or defaulting to 4000 port, and lastly, our app is listening on the port and ready to handle any incoming requests. But so far, it doesn't really do much right. So let's change that by adding our first API route. Now, let's jump into our project. And the way we'll do it is we'll try to keep everything actually organized. And it is a key for scaling an API. And this is how our file will look like. What we'll do, we'll add a folder that we'll call routes. And inside that folder, I'll create a new file that's called book route.js. And basically now what will happen is we'll handle all our routes inside this book router. And first thing we have to do here is import Express from Express. The next thing is we need to create our route. So create a router. And that's very easy. We declare a new variable called book router, and that will be equal to express dot router. Now next thing we will add a get route for, and let's say for example use slash API slash books. Okay, that will be the routes we want to use. So to do that, it is very simple and very straightforward. So we use the instance we create for the routes of book router dot, then you use route, and then you can define your route or the endpoint. So it will be slash books, then dot, and whatever method you want. You want get, you want post, whatever you like. So for now we are doing get, so we do dot get. And inside the get, we will define arrow function that takes in two parameters, your request sending and the request you are getting and the response you are sending back. For now, we'll just mock a response to use for this stage. So const response. And let's say it's an object that have a message in it. And I'll say welcome to my API. And then maybe another parameter attribute called data, for example. And for now, I'll just do, for example, the name of the person. Okay. Then we just want basically whenever we enter this route, we want to give back a response. So res.json, and I'm passing for now this hard-coded response. Then in the end, we have to make this available. So export the router, and that will be very easy. So export default book router. So let's break down this. So we are using basically Express.router to create a router which helps keep our routers modular and reusable. And we added a get route for /API /books. So when the request hit this route, it responds with a JSON object that says, welcome to my API. Now, next thing is we need to go back to our server and we need to update the code here. So first thing we need to import the book router we created. The next thing we want to do basically is mount this router to our app. So what we'll call it, mount the book router. And that's easy to do. We'll just use the instance of our server .use, and then we pass on the first parameter, which should be our base URL, so /API. And then the second parameter will be our route, so book router. Now, next thing we have to add a middleware, okay? And I will tell you, I'll just paste it right here. Then I'll explain what it does and why we need it. It's very important middleware of any modern Express.js application, especially when you are dealing with APIs. And let me break down this for you. First thing, what is a middleware? So middleware is like a middleman in your Express application. It intercepts requests coming into your app and processes them before they reach your route handler. So middleware can do things like logging requests, authenticating users, parsing data from the request body, or handling even the errors. In this case, the middleware is used to parse that JSON data that we are sending our request. Now, you must be asking, what does Express.json do? So Express.json is a built-in middleware function in Express that do two things for us. First, parses incoming JSON payloads. So it looks at the body of the incoming request, and if the body contains JSON, it parses it into a JavaScript object. Second, it attaches the parsed data to the rec.body. So after parsing the JSON, the data becomes accessible in the rec.body object, making it easy to use in your route handlers. This is especially very useful when clients send JSON data in the body of their requests, such as in the post or put request. Now, why do we need this again? Without Express.json, Express would not know how to handle JSON in the request body. If you try to access rec.body without this middleware, it will be undefined. And I hope now that makes sense to you and give better understanding on how this works. Now, this out of the way, we will save this, and what I will do, I will go and try to run my server again. So I'll do npm start. And actually, before I do that, when I import the route here, I have to do .js to make sure it works. Now let's go back to our terminal and run npm start. And let's see if this is working without any errors. So I can see the script is running, and there we go, my server is running perfectly, and I can see the listening console is coming there. Now if we go to our browser, I'll just hard refresh. So you can see now localhost 4000 /API /books is give me back whatever that mock response we added to it. Now, quick note, if you ever run into issues like errors from missing node modules or anything like that, just make sure you delete the node modules right there and run npm install in your terminal, then npm start again. Now, in the next chapters, we'll take this API to the next level by adding more routes and HTTP methods like post, put, and delete. Plus, we will learn how to handle data from the client side using request bodies. So stay tuned and don't miss any part of this tutorial. In this chapter, we'll set up MongoDB and use Studio Treaty for database management and integrate it into our project following the latest practices. So let's break this down step by step. First thing is we need to install MongoDB. So just go and visit MongoDB official website and download the latest version for MongoDB community server and follow the instructions for your operating system. Once installed, just go ahead and install the next tool, which is Studio 3T. Okay, so same thing, just go ahead and click download and follow the instructions next, 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 until it's installed in your system. And this basically will help us to visualize and manage our MongoDB collections and documents. And once both are installed, you'll have the MongoDB Compass installed on your machine, which you can see list of your connections. And the 3T basically, you'll see it like this, which can help you basically to visualize your database. So at the moment, we don't have any database yet, okay? But one thing you have to do once the is installed is just go ahead and connect, okay? And usually if you have MongoDB installed, it will pop up as a default one in the list, and you can just go ahead and select it and connect to it, okay? So for me, I already used this like a week ago, so you can see I've been connected to it last week. But for you, it will be no last connected, so just go select and then connect, and then you should be able to connect to your MongoDB. Once it's installed, next step is actually jump back to our code and we need to set up something called schema. So MongoDB is schemaless, meaning it doesn't enforce data structure. So while flexible, this can really lead to some problems. So to maintain the structure, we define a schema using Mongoose. So a schema acts as a blueprint for documents in a collection, enforcing consistent fields and data type. And after that, we'll be setting up something which calls model. So model basically is abstraction layer in Mongoose. It allows us to interact with the database using methods like find and save and delete. The model is built on top of the schema and used to query or manipulate the data. Now that's a lot of talking. Let's start doing. Let's go back to your terminal and make sure you're pointing to your project folder. And we need to install a new package which is called npm install mongoose. Now that's once installed, we go back to our server and we try to connect actually our application to MongoDB. And we'll be using this mongoose to do that. So first thing is import mongoose. So import mongoose from mongoose. Then the next thing is we'll create a connection. So connect to MongoDB. And the way we can do it, we can do mongoose dot, and then there's a function called connect. Okay. Then inside the connect, we'll accept two arguments. The first one is the connection MongoDB database. Okay. So we'll just paste here the connect. So this is a default connection for MongoDB, and this is actually the name of our database we want to create. So we didn't create this yet, so I will create it later in this chapter. Now, after we do the connect, so next argument, it is basically an object of some attributes, okay? And this attribute basically just help to make sure our connection is working as expected. So we have the use your parser. Basically, this one ensures this compatibility with MongoDB connection, okay? And the second one is use unifying topology, which enable the new MongoDB driver connection engine. Now, once we set up this connection and it is successful, then we'll do the then all what we will do for now is just cancel log something. So cancel log connected to MongoDB. Okay. Then after that, if any error happens, so we'll have a catch block basically. So let me go back to new line dot catch, then arrow function. And also here we'll just display an error. So console.error and just display an error connecting to MongoDB and pass on the error that we will read from our catch block. Great. So again, a recap. So what we have done here, basically this string here, this is the local MongoDB server with the database name book API. So this database name, you can call it anything you like, okay? Then to use new URL parser and use unified topology, they're just recommended options to avoid deprecation warnings in your terminal. Okay, now we are done with setting up our connection. Next thing is to define our schema. Okay, and that will be also very easy. What I will do, I'll create a new folder in my project called models, and I'll create a new file which I'll call it book model, for example. So book model.js, and we have to import Mongoose from Mongoose. And next thing is to define the schema. So define, oops, back to a new line, define the schema. Okay, so the way we can do it is very easy. So const book schema, and that will be equal to new mongoose dot schema. So that is a function within Mongoose. And then basically here it will be an object with all the properties you need for your book. And let's say, for example, we need title, we need author, we need if it's been read or not. So all these are properties that I want my book to have. So I'll add them right here. So an object with the property name, and that property name you pass on an object with the type. So it is going to be a number, a string, a boolean, a date. Okay, so basically you define the type, and then here you can define if it's required or not. Okay, so for example, I said the title and the author are required. I think this one leave it optional, so I'll remove required from here and still type of string. Then the read is also optional because I don't have required here. It is type of boolean, so to be either true or false, and I'm defaulting it if no one had input any details for it. It should be by default false. Okay, so that's basically the schema for our book, how it will look like. Those are the book details, or how it will look in our database, what details it will have. Now, when we create our schema, we will create now a model on top of that schema. So const, I'll create a new model, say book, and I'll add model to it so it's easy for me to read. It's equal to mongoose dot model, so that is a function within mongoose as well. Then you can add the name of your model, so I'll call it book model, which is name actually of your document that will be stored in your database. And then you pass on the schema you created, which is the book schema we created up there. And next thing, of course, we need to export this model and make it available. So export default book, oops, book model. Next thing now is that we want actually to test this, and let's say, for example, let's try to test the get call. Okay, if it will work. First I will remove this from here because we don't need this here, because we're handling, if you remember, our routes in a different file. Then I'll come right there and I'll import first my model that I created. So import book model. If you remember here, we had gotten this response. Now actually I want to get this response back from an actual database. So let's remove this and add a try catch block. And inside here, we'll try to actually get list of the books. So const books equal await your book model that we defined. And remember, this is an instance of mongoose.model. So it have built-in functions like find. Okay, so basically it will find for us all the books with this book model type. Okay, so this one fetch all books from the database. Next thing is basically when we get that one back, I want to return it. So res.json, and we'll pass on the books that we got back. Okay, so this one, oops, response with the list of books in a JSON format, basically. Okay, now you'll see this twinkly red line under await because I'm using await, so the function which is wrapping it should be async function. So I have to come right here and I have to say this one is async function. Okay, and you can see that one now is very happy with that. Now, next thing we want to do basically is just go to our terminal and try to run npm start. And let's see first if our connection is successful. And you can see I have an error. So it says I can't find book model because I have to do .js for now. Let me fix this. And let's stop test and then start it again. And you can see now my server is starting. Okay, so let's see if the logs will come in. And you can see here server is running successfully, and also I'm connected to my MongoDB now. Okay, so if I go up actually to my Studio 3T, okay, and you can see now last access moments ago. So you can see it is really accessing my MongoDB for my terminal, but the we don't have yet a database. Okay, so basically we will not be able to retrieve anything. If you go to the browser and I go back here and let me open my network tab, and let's do a call. You can see here this is my books API. It's not failing, okay, but it's coming back with an empty because we don't even have a database yet, okay, and we don't have any elements yet created. So what we'll do, I will do a quick step here just to create my database for my terminal, okay, and that step's basically called seeding, okay. So we're seeding our database, and when you are seeding the first time, that will trigger also the creation of your database as well. Okay, so let's go back to our app, and I'll create a new file which I'll remove later. I'll not need it, I'll just need first time. So create a new file. I'll go to the root, new file, and I'll call it seed data.js. Okay, and basically first thing we have to do is import mongoose because we'll be talking to our database, and then import our book model. Okay, then we'll set up a connection, same thing we did in the server right here. Okay, so what I will do, I'll actually just copy this one and paste it there. Okay, so basically I'm setting up a connection to my book API database that I want it to be created. Okay, then I'll make a very simple data, a mock data that I want to seed to my database. Okay, so you can see it have title, author, which are required. Also I'm passing the genre and also the read attribute as well. Okay, now next thing is insert this mock data. Okay, so insert mock data to our database. Great, so that's also very easy. So that's your book model dot, and it is a function built in called insert many. Okay, so you're inserting many data, and I'm passing the list of the books I defined there, and then I'll pass 10 functions. So this one basically give me a promise. So when that one is successful, I want you to do the following. So first cancel log, that's mock data successfully seeded. Okay, then I'm just closing the connection to MongoDB. So whenever you open a connection like we are doing right here, when you are done, make sure you close it. So when you have huge applications running, you don't have so many connections open at the same time. So mongoose dot connection dot close. Okay, so we're just closing our connection basically. Then if an error happens, also we have to handle that. So then, oh no, catch. If an error happened, just displaying an error. So console dot error could not seed the database, and then passing on the error as well. Great. So a quick recap again what we have done here. So here basically first thing we just import a model. We open a connection to our MongoDB, same the way we did in our server. And then we created a simple data that we want to see to our database. And then we just inserting actually the mock data into our database using the model dot insert many function. They are passing the mock data. And then we're just making sure when that one is finished, close the connection. Otherwise, if there's an error, just display for me the error so I'm aware of it. Now, this will be simple as going to your terminal, and what I will do node seed data, so the name of my file.js. Okay, so when I did that again, I have same error. I keep forgetting adding .js. So let me fix this and then try again. And there we go. We have a message here saying connected to MongoDB and mock data has been seeded. So we successfully actually seeded our database. Now we can go to our Studio Treaty and you can see I don't see my database yet there. So I can do right click and refresh all. And there we go. Boom. I got my database showing up there, book API. And if you go inside collections, that's your book models being created. And if I double click that one to open it up, you can see here uh, a query is running to find all, and I got the list of my books. So book one, book two, author A, author B, fiction, non-fiction, true and false. Great. So we got our database created. We got it seeded with some mock data initially. Now we can go to our browser and test this as well. So hard reload. So that's pending, it's running, then it failed. And you can see here we got actual problem which called strict origin when crossed origin. So that is a course issue, okay? And that's a major thing we have to do. So to fix that, it's very simple. We'll go to our terminal. We need to add a package. So npm install course and let that finish. So that's finished. We go back to our server, okay? And we will import that course. So import course from course, and then we have to add one actually as a middleware as well. Okay, and I explained earlier in this chapter what middleware is and what they are for too. So we just do this app.use, same we did for the JSON one, we're doing for the course as well. So app.use, then wrap it up and then you pass on the course. Okay, and then you run on your application. Now let's run the servers again, npm start. Let that run. Okay, I can see I'm connected to MongoDB. My server is running 4000. And you can see when I'm back to my browser and I refresh, I get the list of the two books I have. And my API, if I click it, you can see I'm getting a green response back. And if I go to the response tab, you can see that my both books has been added successfully as well. Now that we have a list of the books stored in MongoDB and are fetching them using our API, let's add a feature actually to filter this list based on query strings parameter, such as if it's read or the title or the author name. For instance, if user sends a request and let's say it says parameter read equal true. So we only want the list of the books that have been read, okay? If I hit enter now, of course, I'm just getting everything back. So the API should return only the books with the property read equal to true. Now, how to do that? We need basically to go back to our router and update it to handle the query parameter, okay? So I'll go back here. So all the work will happen right here, okay? So first thing we need to do basically is to achieve this, we'll modify this existing slash books endpoint to include logic for query-based filtering. And this is the way to do it. I'll go inside here and I will define basically a new constant. So the we initialize an empty query object. Okay, so the query is always an object. So create const query equal object. And also I will handle the way to, for example, if someone goes to the browser and enter some property that doesn't exist, it should just give us all the books for us, okay? And just don't hang there or fail to load the details or give us an empty array, okay? So we'll initialize basically an object which is called query, okay? Then we'll destructure the query parameter from the request. So destructure me and my spellings. Let me fix all these. So this structure, the query parameter from the request. Okay, so to do that's very easy. So const, so we know we have genre, we have author, we have title, and we have read as well. Okay, and that will be coming from our request body request.query. Okay, so as we have request.body, we have also something called request.query, okay, which can read basically for us the parameters that someone write right here after the question mark and before that equal sign. So these are the properties we can check and find the books by those properties, okay, because they're the only ones we have at the moment that we can filter by. Now next thing is dynamically basically add filters if a specific query param exists. Okay, so if any of those queries really exist, so let me fix this too, then do the search. Okay, so I'll say if genre, then query dot genre will be equal to genre. Okay, and same thing basically we do for author as well. So I'll just copy this and do author and do here also author and also read from author. Okay, now for the title we'll do a little bit different, so we'll handle the case insensitivity, okay, to match the title. So the way we can do that also is very simple. So I'll paste some code here. So if it is title, then the query title will equal to a regex title and options is I. So what this means, okay, so for fields like title, we use MongoDB built-in regex operator with the I option to perform case insensitivity matching. So this allows partial match as well, okay? So if you're searching for Harry, we will return Harry Potter, okay? So you don't have to input the full name, for example, the title. Even part of it, it should still give us back a full author name with including that part of the string that you are searching for. Now, of course, when we are done with all this, we want to come back with the response, and this find basically we will pass on this query we created right there. Okay, so await book model dot find query. So when it's finding, it will be checking actually the query while finding, then give us the actual books that we are looking for. Now the response should be same, but what I will do, I will add a status of 200. So I have a good response and also handle the error as well if nothing has been found. So I'll just paste here some code. So I'm just dropping an error and also I'm giving a status of 500 with a message saying server error. Okay, and the error side you can handle it in any way you like. Okay, now let's see if, for example, you have a very large data set. So you need to consider a few options, like adding pagination using parameters like limit and page. And that is also very easy to add. What we can do is we can define some, okay, if someone don't pass them, and then we just update them if really someone add them. And that to do that is very easy. So before our book search, we can come right here. I'll define few things like the limit, for example. If there's a limit passed as a param in my URL, then read that. Otherwise, default it to 10. Then the page number, if the page number has been passed, then just read that. Otherwise, default it to 1. And also the skip option as well. So the skip option basically tell us how many pages to skip. So how we can pass these details to our function. So we can come after the find when we do dot limits. So there's a function built called limit. Okay. Then for that one we'll pass of course that limit. And for the skip part we'll just do dot skip. And that basically will tell us which page we will be really reading. Okay. Let's talk about indexing in MongoDB. So index is like a shortcut to quickly find the data you are looking for in your database. So by default, MongoDB scans every document in a collection to fulfill a query. This is called a collection scan, which is very slow for large datasets. An index tells MongoDB to create a special data structure that allows it to locate specific fields, for example, the genre or the author or the title, much faster. For example, in our slash books API, we are querying the database with fields such as genre, author, and title, right? For example, book model.find genre fantasy, for example. So without an index, MongoDB will scan every book in the database to find the ones where genre is fantasy. This can be very slow as the number of the books increases. With an index of the genre field, MongoDB will directly jump to the relevant records, skipping the unnecessary ones, making the query faster and much more efficient. Now, how to add these indexes? Indexes can be added to a specific fields in MongoDB collection, and it is very easy to add. So what I will do, I'll just paste some code. So how to add indexes? Indexes can be added to a specific fields in MongoDB collection. And this is an example, for example. Okay, so the book model.create index, genre is one, author is one, and title is text. Okay, so what this means, genre one means we are creating ascending index on the genre field. MongoDB will sort the data in ascending order. You can also use -1 if you want to, okay? And -1 is for descending index, but for filtering purposes, 1 is very sufficient. Now, author 1, we add another ascending index on the author field. So this is useful in filtering books by the author name. Then basically this will create a text index on the title field. Text indexes are special and allow you to perform full text searches. For example, if I paste next code, book.model find title, we are passing the regex as Harry and the option as I. Okay, so with the text index, MongoDB can search for books with partial matches like Harry and the title very more efficient. Now, the question is when to use indexing. So use indexes for fields you often query, sort on, okay, or you filter on, like genre and author and title. Do not over-index as well. Creating too many indexes can increase the storage size and slows down write operations like the insert and the update. Now, let's close this and let's go back to our actual code. So we go back to our model, and what we will do is we will add actually indexes there. So I'll come here before creating my model, and I'll say, okay, the book schema, add an index for genre 1 and author also 1 and title text. And you can see here I'm not handling the read, okay? And reason why is if you go back to our book route, we are not actually using the read for the filtering, and that's why I'm not doing it. So I'll remove this too, we don't need it. So like if you remember my note was before, don't overuse the indexing, only use it for the items you're using it for filtering or sorting or searching, okay? So that's why in my book model, I'm only adding these three fields for my indexing as well. Now we can use also create indexes like I showed you in earlier example programmatically. So you can also create indexes after a schema is defined, okay? So you can do also this way. Instead of these, come after your book model is created, then we await enter book model create indexes, and you can pass all of them like this as well. Okay, so you have basically two options for your indexing. So again, the benefit of indexing, to recap, is that MongoDB will directly locate the relevant document instead of scanning the entire document. Also, to give efficient filtering, so filtering books by genre or author or title will be now much faster. And also you have full text search, so with the text index on title you can perform case sensitivity and partial matches efficiently as well. Now in this chapter we will learn how to validate query parameters in our Express API to ensure they are safe, accurate, and match our expected format. This is crucial for security and to prevent malicious inputs from breaking your application or compromising your data as well. So why we want to validate an input? So before we dive into the code, let's talk about why validation is very important. The first thing, prevent malicious input. So without validation, someone could send scripts or unwanted data through the query parameter, leading to vulnerability like no SQL injection or security risk as well. The second, ensure data consistency. If we're expecting genre to be string, we should reject anything else like number or object. Third, improve user experience. Validation helps provide clear feedback to users when they send incorrect data. Now, let's meet Joy. So Joy is a powerful validation library for JavaScript. It allows us to define schemas for our data and ensure inputs matches those schemas as well. So Joe also integrates seamlessly with Express, making a very great choice for our projects. So this is the website, so feel free if you want, you can stop the video here and just go quickly scan through it and get yourself familiar with it as well. It is very straightforward and the documentation is very clear and the usage is very easy as well. So let's go back to our code. I'm gonna open a new instance of my terminal. Or actually I'll kill this one first here. And what I will do, I will install a dependency for this Joy in my application. So npm install, and we will let that install. That one is done. The second step basically is creating a validation schema. So we will create a Joy schema to validate our query parameter. And here is what we'll be validating. We will validate the genre because that's the one we are using for our query. And also that should be a string, okay, to avoid unexpected types. And also we're validating the author, which should be also a string. And then optional fields like title should still follow our rules if provided. Okay, now next step it's coming is how to implement this validation our route. So if you go ahead, open your route, and what I will do is import the Joe we installed. So import Joe. Okay, the next thing I want to do is basically create a Joe schema for query validation. And what I will do, I'll just come right before our route definition. Oops. And I'll say Joe schema for query validation. Great. So how we will do this? We'll create a const, okay? Or you can call it anything you like. I'll call it query schema because joy dot object is a function built in. And basically here what we're doing, the schema is defined as an object because the query parameters are key value pairs. So each key in the object, for example, genre, author, title, corresponds to a query parameter. Okay, and this function basically takes in an object as a parameter, and then inside we'll add some certain rules for each query we are expecting. And what I will do, I'll paste some code for the first one, and then I'll explain you what it means. And we'll start with genre. Okay, so here basically all day when they would say in genre, it will be join dot string function, then minimum 2 means minimum characters are 2 characters, dot max 50 means 50 characters are the max, then dot optional. Okay, so optional basically indicate that the genre is not mandatory. If the query does not include genre, validation will still pass for us. Okay, then basically here we are adding some messages for error handling. Okay, for example, let's say someone didn't input 2 characters, only put in only one character, so they will get this error. If someone inputs 100 characters, so they will get this error. Okay, so the messages basically are customizes error messages for validation failure. So for genre, we are following the messages apply string.base. So if genre is not a string, it's like an array or number, the message will be genre must be a string. Then the next one is string.min. So if the string has fewer than 2 characters, then we'll get an error saying Jean must have at least 2 characters. Then we have string.max. So if the string exceeds 50 characters, then the error should say Jean must not exceed 50 character. Okay? Now I'll put the code for the next two and hopefully now it makes sense for you. And I'll paste them right there. After that, we need to go inside our router, and just before initializing our query, we need to do a few things. So first I want to validate the query parameter, okay, using draw. Oops. So how to do that? We'll declare a new variable or object basically. I'll come back to this later, and that will be equal to our query schema that we defined right up here. Okay, so query schema dot, we will have the built-in function, so validate, and this validate basically will pass on our query coming from our request. So request dot query. Okay, then we will add another object as second argument, which will say abort early. Okay, equal to false. Now basically this will validate the query request before we process it or doing anything. It will give us few things. One is the error and then the value of it, which we will use later, okay? Now what we will do with validated, if there is an error, so if error is there, then we'll do a few things. So we'll do send error response with validation details. Okay, so we'll return basically our response, okay, dot status of 400, and then we'll send some message back basically. So dot JSON, and this JSON will have an object that will have success status as false, for example. You can add whatever you want. You will say a message, I will say, for example, validation failed. And maybe also we pass on the error as well. So we'll add an errors, and we'll say that's error dot details and dot map, because it gives us the details as an array. So we'll say dot map, and we'll map through each error, and we'll say give us, or this error, give us back the error dot message itself. Okay, so listing all the details or all the messages, because you can see here you can have one single error message or you can have multiple error messages. So we're just making sure we are returning all of them. Okay, now what we're doing here basically is we're just making sure that our query is valid before even we initialize or we do a research or anything like that. Okay, now next thing I want to do here basically is in the line 42, before reading the join, author, and title from the request.query, now I'll read them from the value I'm getting back from the validation. Okay, so I'll remove this and we pass on the value here. Good, and everything else should be fine as it is at the moment. It should work perfectly. But what I will do, just to make sure, my response I'm giving back to my UI, it's more readable. What I will do is I will just, in the response here, the JSON, I'll not just give back a books, but I'll give back an object, for example. Okay, so I'll do here with success equal to true and data which is equal to the books. Okay, so this one will be looking much more nicer. Same thing I'll do for the error as well. I'll just restructure my response, but this is not necessary. Again, depending on the job what you're doing and the requirements of your role, you may have different things, of course, to give back to the users. Okay, so this is just for the sake of today's demo. Now everything's working. Now we have changed our code, we did the validation. Let's actually go back to our UI and test this if it is working. So let's go back to our books and make sure we are getting our books still. So you can see I'm still, oh, I forgot actually to run my server. So let's go and run my server. So npm start. Okay, Okay, my server is running perfectly now. Let's go back to my browser and hard reload. You can see I'm getting my data back. If you remember, we only have 2 books, okay? And let's try now some queries, okay? And let's say, for example, the first query I want to do is, let's say genre, okay? And let's say that's equal to fiction. And let's see if this one will work. And there you go. We got a success response with true, and then the data is the list of array. And if I click here in my network, you'll see the data is an array, but there's only one object because we only have one book with one author. Okay. Now let's go and try something else. And let's, for example, inside the fiction, I'll just pass on F. Okay. And this one basically will say success is false, validation failed. Okay. The error it says the genre must have at least 2 characters. Okay, so we got actually the second error we listed in our validation. Okay, so we only put one string, but it should be at least 2. If I put fi and hit enter, you can see, okay, it's search, but there is no data with a genre only equal to phi. Okay, now let's try something else where we do unexpected data type. Okay, and let's say, for example, I do genre, and what I will do, or say not only genre, I'll give some string or something doesn't exist, and this one actually should be correct. We do that, then we say, okay, validation failed, genre must be a string. Okay, so we got an error that our type it's not correct. Now, there are actually best practices you can follow and take this even more further, but we will not cover it in this video. Maybe it's for a topic for another video. Where, for example, you can create a separate folder like validators to store all your validation schema for better organization. Also, avoid over validation. Only validate fields you expect to receive in the request, and make sure customize your error messages. So use the messages that like we did, our responses, so to enjoy to provide very user-friendly error messages. Okay, so don't just go in your error messages and just place whatever things which don't make sense to the users. Okay, so in the end, you are building something for the customers, for people, and you have to think from this perspective. If you find an issue, they should understand what is the problem. Now, final things about this. So by adding this job validation, we have made actually our API more robust and secure. And query parameters are now checked against strict rules, ensuring that only valid data is processed. So this not only protects our app, but also provides better feedback to the users as well. So in the last chapters, we implemented now a route to fetch the books, complete with input validation and pagination. Now, before we dive into more advanced and exciting topics, it is a great time to do some cleanup. So as developers, refactoring our code is a key to keeping it clean, reusable, and easier to maintain. And that is exactly what we are going to focus on this chapter. Today we are introducing controllers. So controllers help us separate the route logic from the actual request handling. This makes our code more organized, especially as our project grows. So let's refactor our route step by step. Now, first things is, what are controllers? So think of controllers as the middle manager of your application. Routes handle incoming requests and direct them to the appropriate controller. Controllers do the heavy lifting, validating input, querying the database, and formatting the response as well. So by splitting these responsibilities, we avoid overloading our routes as we are doing now and make our code easier to read and to test as well. So before refactoring, our current get call for /books API handles everything, validation, querying, and also responding. While it works, the code can get really messy if we add more features or routes as well. So here's how we refactor this. We'll move the actual request handling into a controller file, and we'll keep the route file focused on defining the endpoints and delegating the controllers. This sounds really fancy, so let's start doing this. So let's create first a folder, and I will call it controllers. And then I'll create a new file inside, which is called book controller.js. Great. Now, what we'll do is we'll do few imports. So we'll import Joe as we're using that for validation. And then we'll import our model schema that we created, our book model schema. So we're going to import our book model. And then what I will do is I will start actually moving the code I created earlier. So the validation we had right here, I'll just move it out of here and I'll paste it right there. Okay. Next thing, basically what I will do is define a controller, should be just a function. So I say export const. I'll call my controller or my function get books. And that will be an async function. And that will take in two arguments, your request and also the response as well. Oops, that should be a request and a response. Okay, now inside here, basically, what we'll do, we'll move in whatever things we did inside our route right here. So all these things here, I'll just cut them and move them right there to my controller, basically. Simple as that. That's what we were talking about refactoring and having our routes cleaner. Now our controller is actually doing the whole work of actually dealing with the data and querying and validating and so on. Now, after we do this, I save my file, then I can go back to my book route. I don't need these two anymore here, but I'll import my new controller, which is getBooks controller. Okay, then we're inside our route here, inside this get, we remove this async function, and all what we will do is just pass on our controller that we defined earlier. Now, this actually our route now looks much cleaner. So the route is just handling the actual route and the controllers are doing the actual work for us. Okay. So why is this better? Now we have many things here. Why? To answer. Now, why is this better? First thing is separation of concerns. So the route only defines the endpoint and delegates logic to the controller. Second, improved readability. So by splitting the logic into a controller, the code now is much easier to follow. Then we have reusability. The controller function that we defined here can be used for another endpoint like post or post as well. Then easier testing. Testing a standalone controller function is simpler than testing a combined route as well. Now, let's actually run our server, and I can still see my server here is running, it's working perfectly. Let's go back to our browser and let's actually test this, our hard reload, and you can see everything's still working as it used to be earlier. So now with this refactoring done, our project is now in better shape to handle more complex features in the next chapter. Okay, so in the last chapter, we built a feature to filter books using query parameters. Now let's shift gears a bit and focus on fetching a single book by its ID. So this is a super straightforward task, but it is such a vital feature for any application. So whether you are building a book library or e-commerce site or a movie app, fetching by ID is everywhere. And what I mean by that, if for example I now have list of books, I want to pass the ID just like that in my URL, and then I want to see the actual details of my that single book, right? But that we don't have at the moment. So let's dive in and get this working step by step. So let's jump back to our code and I'll just close my terminal and make this thing a little bit bigger, little bit. Okay. Now, what we are going to do is, or what we are building. So when we say get a book by ID, what I mean again is that we want to take an ID and add it to the end of the URL and use that ID to fetch that exact book that matches it, right? So what we'll do, we'll start by our controller and we'll define a new controller that will handle getting a book by ID. So let's go here and we'll say here get book by ID, and we will define a new function. So we'll do first an export const get book by ID, okay, and that will be an async function that takes in two arguments, your request and of course your response. And we will have a try catch block to handle any errors, of course. Now, first thing is we want to actually extract that book ID from the route parameter. Okay, so extract the book ID from the route param. Okay, so that is also easy to do. So const, I'll create a new constant. Okay, and I'll say no. I'll say const, and then I'll actually use a singleton to access the book ID property within my request dot params. Okay, so easy as that. So also have the book ID actually pass as part of parameter. So just try to read that property directly. Okay, now when I have my book ID, next thing is to fetch the book from the database. Okay, and to do that, it's very simple. Just say const, and we can say again book, that is my response, and that will be equal to await, and then my book model that we created dot, and you have a function called find by ID. Okay, remember here we just used the find function to give us everything back. There's another function which called find by ID, which find a document by its ID. Okay, so and I'll pass on the book ID I stored earlier right there. Okay, great. Now we want to do a few things. We want to check, of course, if that book exists. So check if the book exists. Okay, so we'll say if book does not exist, then we want to return something. So I'll return a response with a status of 404, means not found. And then I'll just mark a response with this. So JSON, then I will say success is false. And I'll say the message book, or actually like this, because I need to pass the ID. So I'll say book with ID of book ID not found. Simple as that. Okay. Now this in case if the book doesn't exist. If it does exist, then great. So we'll send that response back. Respond with the book data. Okay. And then we just give a response back with status of 200 means green. Then this is our response JSON, and it will have a success of true, and then we'll send our data having the value of the book that we got back right here from our database. Great. Then we have the catch block. So again, this is just error handling. So I'll just paste some code here again. I'm just logging out the error and then sending a response which says 500. I'm saying that some generic message saying that an error happened while fetching the book. Great. Now we created a controller. Next is go and hook this to our route. So I will import my controller. So get book by ID. Now this will be kind of dynamic, right? Because we will be reading that parameter or the book ID from our URL. That means that we have to go and actually create a new route, okay? So we say book router dot route, and I will say, for example, slash books slash column, then book ID. So whatever the name that we called, oh, here I did a mistake, should be a comma. So whatever the attribute or the param we used here, that is the one will be used there. And we will add actually a method. So same here with this, so dot get, and then we will pass on our controller. So get book by ID. And that's it. This should work. Let me check now my server if it's all good. And actually it's complaining about something. So I'll just go and check what is complaining about. So we can't find this more. Okay, book controller. So basically I have to go here and do .js and save this. I'll just go back to my terminal and stopped it, run it again, npm start. Okay, now let's go back to our browser, and what I will do, I just pick up an ID and we're going to test it. So I'll come here and do slash and then our ID. And there we go. You can see our response came back successfully. Okay. And we got that JSON print in our screen. So success is true. And that is our actual current book details login right there. So far we have built some very cool features, filtering books, fetching a book by ID, and even more than that. But now it is time to spice things up a little bit, and we are going to learn how to add new books to our database using a post request. So think of it, what good is a book library app if you can't add books, right? So let's fix that. By the end of this chapter, you will know how to create a post endpoint, use body parser to handle incoming data, and test it all in Postman. So grab your coffee or tea and let's get really started with this. So what is a post request? A post request is like filling out a form and submitting it. You are sending data from the client, that is you, to the server. In our case, we will send book details like title, author, and genre to our server so it can add them to the database. But first things is we need to install few dependencies. So go back to your terminal. I'll stop my server right here. And we need to make sure we can handle the JSON data. So in modern Express versions, body parsing is a built-in, but let's double check this. First, we're going to install npm install body parser. Okay, let's hit enter and let that install. Once installing, we will go back to our server app.js and we will add another middleware. So we'll just go right here and do app.use and then we'll be passing that body parser. So I have to go and import it. Import body parser from body parser. Then I'll come back inside my use function. I'll say body parser dot JSON. And boom, now your app can parse JSON data from post requests. So easy, right? I'll click save. Now, time to create our post endpoint, and we'll go back now to our controller file to create the function or the controller. So, post calls, okay? So we'll create a new one with the export const. I will call it add book, and that will be also an async function which checks in the request and the response. And we will have, of course, our try catch block. Oops, try catch block. So what we will do is, again, inside our try block, we'll try to access the details we are sending in the request body. Okay, so const, and let's say we are trying to access, for example, title, author, and genre as well, for example. Okay, and that will be equal to our request.body. Nice. So now we're accessing the details. For example, the user is sending through that API call, right? Now, next thing is some validation, okay? Now, I'll do one thing. I'll go back to my book schema, okay? And actually, the genre is not mandatory field. So, because of that, I'll just remove it from here, okay? Now, my validation, the title and the author are required ones. So, I'll say if my title doesn't exist or my author doesn't exist, then actually we have an issue here, right? We can't save this book. So I'll return a response, okay, with a status of 400, and I'm sending back some response So JSON, I'll say success is false. Okay, we didn't save your book details, and the message will be saying that please provide title and author, for example. Okay, so that is if this title and author doesn't exist in our post request, right? Now let's say if we have all details and we are happy. First thing is we need to create a new book, okay? And how we can do that? I'll create a new variable, const new book, and that will be equal to new, and you will add on the book model, okay? So that is our schema, right? So book model that we created, and we'll pass on the title and the author. Great. Now we created the new book. It's time to save it to our database. So save to database. And to do that, there's a built-in function. So await new book dot save. Oh my God, this is so easy, okay? So just like that, you saved your new book to your database. Now, if that one's successful, that's why you're using the await, then we'll respond, of course, with a success message, okay? And give back the new book details. So response dot status, which will be 201, and then dot JSON should be the response sending back to the user. So success is true, and then we say the message for saying book added. Oops, let me fix this. And of course, we'll send back the data. So data is the new book. Okay, great. Now the error side again is just generic catch error. So I'll just add some code right there. Okay, now we created our controller. It's time to add this to our router. It's simple steps you have to keep following each and every time. So I'll say add book. And now this of course also will be using we'll be adding a book to a list of books. So we'll go back to this route, and as we have get, we will add a post. Okay, and we'll pass on the new controller add book. Great. Now we are done with the code side. So, and this is actually a little bit recap what's happening. So first thing is what we are doing here is we are extracting actually the data like the title and the author, okay, from the request body. Then we are ensuring that all fields are valid. And then we save the book to our database, okay, after creating the new book model instance. And then we are sending a response back if there's a success or error, so we just respond accordingly. Now, time to test this. So how we can test this? We use a tool which is called Postman. So if you don't have it, just go and install it. Just a Postman, and it's very easy. You can use the the browser app, or you can just actually download it and install it on your machine and run it as a desktop app for yourself as well. And it's just very easy and forward. It's just like you download and you just click next, 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 and you're done installation. Easy as that. Just take on all the default options if you don't have Postman already on your machine. Now I have Postman on my machine, so I'll go ahead and open Postman, and then I'll just click this new button right here, okay? And here basically we'll add the URL to our server. So I know the log server is my local host on port 4000. Then we are accessing our calls on /API/books, okay? And what I will do, I will just go to the header. I'll just go to the body. Then you can go and select row, and what I will do is just paste this row data. So title, the Grace Gatsby, and for example, the author, first called Fitzgard, and then genre is classic. Now let's click send. And this one came back with 201 created, which is very successful, right? Now what I will do, I'll go here and trigger this call to make sure I'm having now 3 books. Okay, so let's click send. And you can see now I have 1, 2, 3 books I have now in my database. Now we can add new books to our library using a post request. But what happens if you spot a typo or maybe a book title changes like a SQL update or something fancy? That's where the put request comes in. Now we are going to learn how to update a book in our database. So buckle up because we are diving into the world of updating data. It's like giving our books a makeover, but instead of hair and makeup, we are fixing the titles, authors, or genres as well. So what is a put request? A put request is used to update an entire resource. Think of it like this. You are placing the old book with a shiny new updated version. If you only need to update part of a resource, you may want to use batch. But now we are focusing on the put, so we'll keep this simple for now. So in our book router, we will add a route to handle the update. But before I do that, let's actually create a controller. So we'll go open up your book controller and we'll scroll down and we'll define a new function and we'll say export const, let's say update book. Okay, and that will be also an async function, taking in the request and also the response. And of course, we'll have our try catch block right here. Now, first thing we want to do is get the book by ID from the URL that we want to update. So get the book ID. Okay, and that will be simple. We already have done that before. So book ID will be reading from our request dot param. Nice. Now next thing I want to do is get the updated field for our request body. Okay, get the updated fields from the request body. And that's also very simple. So const, and we want to access the title, we want to access the author and also the genre. And that will be coming from our request dot body. Great. Now we access these things, we have to run some basic validation, okay? And again, like we did earlier, we just check if the title and author exist because they are mandatory fields, okay? So validate. So we say if title doesn't exist, let's say for example, you're passing on an empty title or the author does not exist, then we'll give back basically a response with a status of 400 and some message saying that please provide the title author, and I'll remove the genre because that one is not a mandatory field for now for our example. Now we run the validation. It's time to update our book in the database. Okay, so the way to do that again as well is very simple, and that's our next step. So find and update at the same time the book by ID. So we'll declare a new variable const called updated book, and that we call equal to await our book model we created earlier. Then the Mongoose give us a built-in function called find by ID and update. Simple as that. Then in this function, the first parameter is the book ID. Okay, so the ID of your document you want to update, and the next one will be the details you want to update. So I want to update the title, I want to update the author, and I want to update the genre as well. Okay, so here basically we're just updating the fields. Now I will add a third prop or param to my function, which will be an object. Okay, and basically here we'll just tell it to return the updated document and also run some validators for us. So we'll do new true, and I say run validators. Okay, and I'll say that also is true. Great. Now we find our book and also we update it in our database and we get the updated version back. Now we have to handle few scenarios again here, okay, before we give back a response. So Let's say if the book is not found. Okay, let's say you try to access the book by ID, but you didn't find any book. So we'll handle that. So I'll say if updated book is null or undefined, then again we'll just return some message with a status of 404, means not found. Okay, so success is false, and I'm displaying some generic message saying book not found. Let's check the ID. Okay, so now we check the book, we know that the book exists. Now last step is basically return your book, that if you find it and you update it. So we've come a response with status 200, and we are returning success is true, then a message saying book updated successfully, and a data which I'm assigning back the updated book I get back from my database. And that's it. The next thing basically is the error handling, which we are doing the same way, just logging out an error and status of 500 as a response with success of false and very generic message right here. Okay, now this is done. Next thing is go to our router and access our controller, and then we'll just add actually this controller to our route right here. Okay, because same thing again, we are accessing dynamic param, which is the book ID. So we will add here a put call that will be assigning our update book controller we created. Great. Now next thing, of course, to go and test this. So I'll go and open my Postman, and let's retrieve actually the list of my books. Great. And what I will do, I will go try to find this book. Okay, book 1, author A, and let's update one. So we'll come here, and inside of post I will have a put, and we have slash API slash books, and then slash our ID. Okay, then we'll come to the body here, and what I will do, I'll go to the row, and let's say I want to update the title and the author, and I will add Lulu Awesome Book 2, and here I'll just say the author is Lulu 2. Okay, now let's go and send this. And you can see here I got a response of 404. And actually I find here I did a huge mistake. I'm checking actually the function and not the constant I created. So let me fix that. And let's go back to our Postman. And let's try this again. And now you can see it's working as expected. I got a 200 response back. And if I go click the body, I'm getting back my book, which the genre is still fiction, read is still true, but now the title and the author has changed. And if you remember, that is the first one we selected here, okay, which before it was book 1, author A. Now if I go and make another get call, I should see this updated too. And there we go, you can see it got updated immediately. Now the title is Lulu Awesome Book 2 and the author is Lulu 2 as well. Now, what are the key takeaways? So the put request basically is perfect for replacing a resource entirely. And error handling always validate for us the inputs and check for missing resources. Then we use Postman to test our API and make sure they are all working as expected. So we have learned how to add books with post and replace the entire books with put. But what if you just want to make a small change, like correcting a typo in the title or updating just the genre? That's where patch comes in. Think of it as giving your book a little tweak, not a complete overhaul. It's like fixing a single page instead of rewriting the whole novel. So let's roll up our sleeves and get this patch party started. So what is patch request? Patch is like saying, hey API, I only want to change one or two things, not the whole object. It is efficient, neat, and makes you look like a pro who knows how to keep things lightweight. Now, let's create our controller that will patch the book for us. So I'll define a new function. I'll call it patch book. And that will be also an async function taking in a request and response. And of course we'll have our try catch block. Oops, try catch. And inside, of course, first thing we need to do is get the book ID. And I think now you'll know how to do this. So const book ID, that will be equal to our body dot param. Oops, param. The next thing is get the updates from our body request. So get the updates. So const, I'll call them updates. That will be equal to request.body. Next thing is to validate that there are at least one field to update. Okay, and what I will do, I'll paste a quick code so you don't see me typing the whole thing. Basically, we are just going through the keys within our update. So update will be an object of key pair values. So we'll check if the length of it is 0, means there's nothing, it's an empty object. Okay, then return a response of 400 and say please provide at least one field to update. Okay, so that's a basic validation we are running, making sure when you do this API call you are actually passing some field to update. Now next thing I want to do is find and update the book. Okay, and that's also to be almost very easy, similar what we have done before as well. So what I will do, I'll also paste some code quickly here. And also doing, I'm creating a new instance which will hold my saved or updated book from my database. Then I'm doing a wait for my book model we created, which gives us also the same function we used before, find by ID and update. Then the first parameter is your ID of your documents, which is our book for now. Then the updates, so only the updates field will be passed on. And then again, same thing we did before here, we just added an object with few properties that helps to update and validate our input as well. Okay, now next thing, I think now you might have an idea what we'll do. Now what if the book doesn't exist? If we give an ID for book doesn't exist, so we have to handle that. So if the book isn't found, then give a response back with a status 404 with success or false and a message saying book is not found, please check your ID. So some meaningful message. Now if the book is found and everything is good, the validation is good, then we will give back a response with the updated book details in the response. So if I give a response of 200, success is true, I'm displaying a basic message saying book updated successfully, and the data I'm passing on the updated book details I'm getting back from my database. Then the catch block, basically if any error happened, we are just displaying a generic error at the moment, passing on with the success set to false, and also throwing an error log as well. Now that is it. We have created basically our controller. It may seem a lot, but it is really simple and very straightforward as you think about it step by step. So the things were happening. First thing is that we extracted the book ID, which comes from our request actually dot param. I did here a spelling mistake. So request dot param, that's where we get our book ID. Then we find the fields that we want to update from our request dot body. Then after that, we check if the request body is empty, means a no update. If it is, we send back an error saying, hey, give me something to work with. Then we use the find by ID and update to apply only the fields you have provided. Then of course in the end we are just doing some error handling. If the book isn't found, we send 404. If something breaks, right, then we catch the error and we send back a 500. Now I need to save this and go back to my route and add that to my route. So I'll import my new controller, which is patchbook, and then I'll just add it to my route. So I'll come right here, I'll say dot patch, and I'll pass on my controller I created. And basically that's it, we are done. This is very simple. Now we'll go to our Postman, and before we use a put method, now we'll use the patch. Okay, and what I will do now, I'll just pass on, for example, the title. Okay, and I'll say Lulu Awesome Brook number 3. Good. Now let's send this. And there you go. I can see that I got 200 response back, and also you get back all the details of your book with the updated field right there. Okay. Now, key practices for this part. So you use batch basically for partial updates. So only update what needs to be changed. And we validate the inputs. So always we check that you are getting a valid and useful data. Then we are handling the errors gracefully as well. Okay. So always the users are having some meaningful error handling that can guide them through on what is the problem. Now to wrap up, that is it. You know now how to patch a resource. This is super useful for those little tweaks you don't want to create a whole put request for it, like fixing typos or adding a missing genre, for example. Now, next up in this next coming chapter, we will tackle the final boss, which is the delete request. So, time to learn how to say goodbye to a book right away if you don't need it. Until then, keep coding and keep laughing. Okay, now we are diving into the lead request, which lets you say a clean and professional goodbye to unwanted books in your library. Let's learn how to do this step by step with the best practices and, of course, some laughs along the way. So, what is a delete request? Delete does exactly what it says on the tin. It removes a resource from your server. No questions are asked. It's like the hasta la vista baby of HTTP methods. So you point to a specific resource using its ID, send the delete request, and boom, it's gone forever. So no pressure. Now let's add our delete controller. So I'll go back to my controller here and I'll define our new function, export const delete. Oops, I have to remove my capitals. So export const delete book. Okay, and that will be also an async function. Takes in a request and a response. And we will have our try catch block, of course. Okay, now of course first we want to do is finding the book by the ID, okay, as we are doing all the time because we are deleting a book by its ID. Then we will try to find that book in our database and delete it as well. Okay, and good for us is that Mongo's have a built-in function as we were using before that's called find by ID and delete, and that takes in a single parameter which is the ID of your document, and at the moment we call it the book ID. Now first thing you have to do, like we did for the update, is check does the book exist that you want to delete. If it doesn't, I want that to throw an error and just stop running anything else. So if the book is not found, we're giving back a response of 404 with success set to false and a message saying book not found, please check the ID. Now, if we find the book, of course we want to have a 200 response saying that we find the book and we delete it as well. So we're giving back a 200 response and success set to true and a message saying the book with this ID deleted successfully. And in the end, our try catch block is same as always, very generic code that just handle generic deleting message error for us. Okay, now we create our controller. Of course, next step is to edit our routes. So I'll go back to my route. I'll import my new controller and then we'll just add it here. I'll say dot delete and I'll pass on my controller which called delete book. And that is it. Very simple, very easy, very straightforward. Now again, let's go back to controller and do a recap. So first thing is we extracted the ID of the book to delete and we pulled it from the URL using the request.param. The next thing we did is we tried to find and delete the book and we used the built-in function in Mongoose, which is find by ID and delete function, to look for the book by its ID and remove it from the database. If the book is not found by its ID, we respond with a 404 message. Otherwise, we just give back a 200 response. Then we are just handling the generic error here by throwing up a 500 status code with an appropriate message. Now, time to go and test this in Postman. So what I will do, actually, I'll stop my server so it pick up my changes and run it again. And this is running successfully. So I will go back now to my Postman. And what I will do here, instead of the patch, I'll just do a delete, and I'll try to delete actually the book we updated earlier, okay? So Lulu, awesome book 3. So delete, we don't need any body parameter or anything like that. We just need the ID in the URL. And let's go and hit send. And you can see here the book response, the delete response is two-handed, which means it's successful. And I can see here the message saying the book with this ID was deleted successfully. Now let's go back and test this. So I want that when I get a call book, I get book API call, I want to see only 2 books. So let's click send, and you can see now I only have 2 books listed there. Now we are going to dive into unit testing, the magical practice that ensures your code behaves itself even on a bad day. Let's keep it simple, step by step, and maybe a little funny, because what is life without a bit of a debugging humor? Now, why do we need a unit test? So imagine you have built this fancy house of code. Wouldn't you want to know if the foundation can hold up? That's what unit testing does. It checks individual pieces or units of your code to ensure they work as intended. Also, future you will thank your current you for writing these tests when something inevitably breaks. Trust me in this. Now, first thing we'll get started with is we need a testing framework. So for this tutorial, we'll just use Jest, the all-star of JavaScript testing framework. So I'll go to my npm and I'll install npm install dash dash save dash dev, and we'll be installing Jest. And I'll open my package.json while that one's getting installed. So next thing, we'll go and update our test file and just remove this and add Jest to it. And basically here what we are doing is we're just using Jest to run our test command. Next thing, I'll save this and go and make a new directory or folder. I will call it test. So inside this folder, basically, we will add all our testing, and this is where all our testing magic will live. Now, next thing is we need to test, for example, the delete book. So let me open the controller, and let's maybe just test the last controller we created, which was about deleting. Okay, right there. So to do that, I will go to my folder and I'll create a new file that I will call book controller.test.js. And first thing I want to do is import the controller I want to test. So delete book controller. And then I will also import the model that I use for creating my book. So book model. Then what I will do again, I need to create a mock for the book model to prevent actual database interaction. So I'll just paste some code here. We don't want to do actual any integration of the database when we are testing. I'll go here action add .js as well, .js to make sure everything is working properly. Now, next thing is to start creating our test. So we'll start with a describe function to describe our test. And then the first will be just a text to describe what is your test about, okay? So I'll say this is about delete book controller, for example. Okay, that's what I'm testing. Then the second argument will be an arrow function where actually all your tests will run. Now, maybe for delete book, we have to test different things like should a delete book be successful, or for example, when it returns 404. So we have many tests we need to describe, okay? And we can arrange it like this. So we can do it, okay? And again, the first argument can be a detailed description of what you want to do. And also here should delete a book successfully. Okay, then the next argument will be an arrow function, and this actually we will do our test. So first thing is I will create a mock book ID. That's what we're using. So const mock book ID, and that will be equal, for example, to 1 2 3 4 5. Okay. The next thing is we want to actually mock the resolution of find by ID and delete. So if you remember in our code here, by using this function to find actual book in our database. But here we will actually just mock it and pretend that we really find it and resolve it. So I'll go and paste some code here. So that's our book model, and that is the function we use, find by ID and delete. Then we can access something called mock resolve value. So we are mocking the resolution of this request with a value, means a response coming back, and we're giving back that mock ID we created, and I need to fix the spelling. Okay, and I'm giving, for example, a title as mockbook. Okay, so basically it acts like it actually find a book for me in my database and give it to me back. Now next thing I want to do is create a mock request and response as well for this call. So I create here a request with a params of book ID, and I'll be passing the mock ID I mocked right there. Okay, then I'm mocking up also the response, which is having status and the JSON coming back, and that's having a just.fn and then here just.fn dot mock return value. So we're just actually just mocking everything here, okay, just to act like something really is behaving behind the scene. Now next thing is we want to actually act, we want to trigger our controller. Okay, so what I will do here, I'll just await delete book, that's our controller. Okay, and then we're passing the mock request and mock response, and because this one is a, I need to make my test an async test to make it work. Okay, now, next thing is the assertion. Okay, so what we are expecting from this test. Okay, so let's say here asserts. Now, I'm expecting the first thing is the book model and find by delete should have been called. Okay, so whenever I trigger this delete book, this function should be triggered, right? It is part of my controller. So I want to test that, and this is wrong here. So I'll say expect, and then I'll say the book model dot find by ID and delete. Okay, I'm expecting this to have been called, and also it should be called with an ID. If you remember, when this one is called, it's called with actual value passed on, which is the book ID. So I'll use to have been called with, and I will pass on the mock book ID I created right there. Great. So this is the first thing. Second thing I want is that if my call is successful, I need to have a response status back with 200. Okay. So again, if you go back to our controller, if everything's good, the status is 200. So I need to test that as well. So again, it's same thing. Okay. I will come under here and I'll say I'm expecting that my mock response I created here dot status should be back with or called with 200 as a value. Great. Now the next thing is the response itself that we are turning right there. Okay, we need to test this. That's why I get in a response back with the success and the message response as well. So we'll go here. Also, I'm expecting the response.json to have been called with a success equal to true and a message saying the book ID. And I have to make sure that this is the same thing. So I'll just copy this and paste it here and make sure my book ID is correct. Nice. Now, this our first test we write, okay? Now we can add more tests. For example, I want to test a scenario where the book is not found, okay? So which will give us back a 400 response. So what I will do, I will quickly paste some code and we'll just go through it as well. So you don't see me typing each and everything. So I'll come right here and I'll paste this, I'll close my terminal and we'll go through it. So here basically what I'm doing is that I'm saying my test it should return a 404 if the book is not found. And this is also an async test because we'll be triggering the controller that we have to await for it. Now, first thing again, we created a mock book ID as well. Then we try to trigger the functionality to find that book in our database. But now we are mocking the resolution with a value of null, means the book wasn't found, okay? And here, if we go back to our code, it will throw us right here, okay? So we are getting as a null for the response. Okay, so I'm mocking back this value. Now we know if this one is null or undefined, we need to get a 404 response, right? So that's what we're trying here. We mocked again the request and also the response. Then we trigger the call to our controller with the mock details. Then again, we're expecting the status to come back with 404 and also the response to have been called with a success of false and also the message book not found. So whatever response we're giving back here, that's the same thing we're expecting here to happen. Now here we write two tests. Now let's see how we can run these tests, okay? So if you remember, we called our script test. So I'll go to my terminal, I say npm space and the name of my script. After you run the test, you might find some issues with compatibility issues with JS and the test files. So I highly recommend you to go and do the following if you face these issues. First thing is that make sure in your package.json you have type module here. Next thing is you will go and create a config file for JS, okay? So I create here a just.config.json. Then I just add here some configuration saying that we'll be using transformation, look at the JS files, and we will be using Babel.js to handle that for us. Which means you have to go and install few packages just to keep them in your machine, so in your project. So we go here and you go npm install dash save Babel.js and Babel core and Babel preset in as well. Okay, so after you did this config, just config, you will to add another config for Babel RC. Okay, so I created a .babel RC file here in the root of my project as well, and I added this basic configuration saying use the Babel preset environment to run my project. Fix basically all your problems. Our script is still nice and clean, so I'll run you the test just now. I will go and close all this and I'll run my test again. So npm start, oh no, npm test, and let's see if this is working. And there we go, you can see my tests are running. So this is my delete book controller, and my first test, which is about should delete a book successfully, have run and worked and passed all the tests. Same for the second one, which I'm testing the 404 scenario as well. Now you can feel free to pause the course here and try and add more tests if you want to cover the other controllers as well. Basically, you just be following the same structure, okay? It's just the mock data you'll be using will be a little bit different, depend on the response you're expecting from each controller. That's it. Now, let's break down again what happened here. Firstly, we are mocking the database, okay? So we don't want to mess with our real database during the test. So we just use just.mock to create a fake version of our book model, okay? Then next thing is that we are simulating the request. We created a fake rec and fake res, okay, object to mimic what Express passes to our controller. Then we are just testing here the happy path, okay? So the first test check that a valid book ID deletes successfully, and the second test ensure the right response when a book isn't found is coming true as well. And the assertions we're using, so we use the expect function, okay, to make sure functions were called with the right argument and the responses matches what we want. Now we will step into the wonderful world of integration testing. It is like team building exercises for your code, making sure all the moving parts work together nicely. So if you have done unit testing before, this is like leveling up. So today we will write integration tests for our API endpoints. And don't worry, I'll keep it fun and break it down step by step. So let's roll up our sleeves and dive right into it. So first things first, we need the right tools for the job. You are probably already using Jest since you are here, but you will need a super test. It is a handy library for testing HTTP requests. So I will go and install that library. npm install super test dash dash save dash dev. Great, done? Cool, you're already winning at life. Now, step number 2, let's create a file for our integration test. So in our project structure, we will add a folder under the test folder. So I'll go and add a folder called integration. Okay, and then inside I'll create a test file which I will call book controller.test.js. Okay, so we're creating another test file for our controller, but this will be an integration test. And here what we'll be testing today. We will be testing the get call API, okay, slash books, and also we'll be testing the post call to ensure a new book gets added successfully, okay. Now first thing we need to do is import the new library installed. So import request from supertest. Next thing is to import our server, and next thing is to import our model. Nice. Next thing is we don't want to mess up the real database, so let's use an in-memory database for testing. If you don't have it yet, let's get it installed. So we will go to our terminal and run npm install mongodb memory server, then space, and we'll say dash dash save dash dev. So all their dev dependencies, because we only need them during the development lifecycle. And what I will do, I will import the Mongo memory server from the new package, and also import the Mongos that help us to talk to our database. Okay, now that one is done. I want to create a variable which I'll call it Mongo server, or actually Mongo server, yeah. And I will not I'll not assign anything at the moment. Now, next thing I want to do is define some set of things I want them to happen before every test and also after every test. So what I will do, I will paste some code here and I will explain it what it does. So basically the before all, it is a function that runs for the test and to run before any test runs, okay? So basically we are saying the Mongo server assign it this fake memory we created, okay? So we're creating one. Then we are creating a URI using the Mongo server.get URI. Then we are connecting to our database, okay? So before any test runs, go ahead, create a mock server and connect our server to the database, okay? And in the here, or what we are doing is the opposite. After every test finishes, make sure you go and you close the connection to the database, okay? Disconnect it, and also make sure you stop that mock server from running. This way, if you're running 2 to 3 tests, they don't go inside with each other and create problems for you. Therefore, your test will not be very clear. Now this basically will ensure our tests don't interfere with real data. Phew, and that's down out of the road. Now, let's test the slash books endpoint, okay? And to simulate a real world conditions, we will pre-fill the database with some book, okay? And same thing as we did for creating a mock server and connecting, then disconnecting, we will do the same thing for creating that mock data as well. So here basically what I'm saying is that before each test, I want you to go and create some data in my database, okay, which is mock database. Then after each test finishes, make sure you go and delete any data you have in your database. So that's all what we are doing here, okay? So here I'll add some comments. Create mock data before each test. And here clean up any data in database after each test. Okay, great. Now we will check if the endpoints return all the books. Okay, and same pattern we did for the unit test, we'll be almost doing the same thing. Okay, so you'll have a describe function, okay, that describe what your test does. Then the first part actually will be the description, and always make sure you have a meaningful description, because in a real-time project you have huge files, a lot of unit tests. You don't want when you run your script on your terminal, you don't know what it tests, what it does, what the test does, or what files it is taking care of. Okay, so make sure always these descriptions are really meaningful. So I'm testing the get call for slash books. So that's my main description. Then inside will be all the sub-tests I want to run for that endpoint. Okay, so the first thing I'm saying here, it should return all books. So I'm covering the happy path. Always we cover the happy path first, and then we start finding, the conditional ones like errors happened or catch blocks and so on. So all I'm doing here is basically I'm getting a response when I'm waiting for a request on my server, and I'm getting my slash book call. Okay, so basically what we are doing, if I open my route, we are basically testing this part right here. Okay, that is giving us back the list of the books stored in our database. So that's what we're doing right here. Then, of course, when that's finished, I'm adding what I am expecting. So I know that my book controller, if I go up to my first controller I created, get books. So I should basically, if everything is happy, without any querying or anything, I get a response back with 200 with a success set to true and data set to books. Okay, so that's what I'm doing here. So I'm expecting my response of status to be 200 and response.body.length to be 2 because I have here 2 books that I marked, right? So I'm expecting to have 2 books in my response, and also I'm checking that the first response title is this. Okay, so whatever the mock data we did, so this is the first book. I'm expecting the first book I will get in my response to have a title of The Great Gatsby. Okay, and you don't have to check each and everything. Like I said, unit tests, you should test what you need. Okay, if I'm testing by title, that means I'm getting my right book. I don't need to add author and genre as well. Okay, so keep it minimal, but whatever it covers your work. Now, this basically is testing my get API call for slash books. Now let's try to write a one for the post call. Okay, so I will come inside here, and this will be again a different endpoint, which means I need a new describe block. So I'll go here, I'll create a new describe block, which is all about the post calls to slash books. And I'm doing one test at the moment, which is again the happy path. And I'm saying I should be able to add a new book. Okay. And here basically I'm marking some new data. Okay. For a new book to be added. Then again, the response, I'm waiting for my request while listening to the server. And that is triggering the route of dot post pointing to slash books. And then I'm sending the new book I am marking here. Now, if this one is all great, what I am expecting, if we go back to the book router, you can see here the status is 201 if everything is happy, okay? And we have a message and then new book passed to the data. So that's what we are testing. So the status should be 201, okay? Then I'm checking the response I'm getting back. That's the title in that response of the book. It is equal to the one I created now. Okay, so I'm just matching the values to to compare the one I'm sending against the one I'm getting back from the database. Okay, if they are the same, means everything's working properly. Then here all I'm doing is I'm doing a book ID booking database. Okay, so I'm finding the book I created. Okay, in the database. Then I would check that that book does exist in my database. Therefore, I'm just saying I'm expecting that the book should not be null. Okay, it should be saved in my DB. And that is it for the happy path of both get call and the post call as well. Now we can go and run our tests in our terminal and see if this is working. You can see all our integration tests are running properly as expected. Now you have made it all the way to the chapter 18, so give yourself a high five or just nod proudly at your screen. Now we are diving into Hypermedia, that magical layer in APIs that makes them smarter, more dynamic, and honestly a lot cooler. By the end of this chapter, you'll understand what hypermedia is and why it is important and how to implement it step by step in your modular API project. So let's make our APIs talk like real pros. Now, simple question, what is a hypermedia? Let's start with basics. Hypermedia is part of the hate oath principle. HATO stands for Hypermedia as the engine of application state. Yeah, I know it sounds fancy, but just stick with me, please. In plain English, instead of just returning raw data in API response, we also provide links to other actions the client can perform. For example, if you call /API/books, the response might include links like want to add book, go to API/books post. You want to see details, go to API/books/column ID, get request. So these links guide the client through the API like a map. Now, why we want to use a hypermedia? So here is why hypermedia is awesome. First thing, discoverability. Clients don't need to hard code routes, they follow the links you provide. Second, flexibility. If your routes change, the client doesn't break as long as they rely on the provided links. Then third, dynamic navigation. The API can tell the client what is possible at every step. It's like the API is saying, hey, I got your back, here where you can go next. Next thing we want to know now, how to set up Hypermedia and enhance our API. Now we will enhance the get call for /API/books endpoint to include hypermedia links. And here's our plan. First, we'll update the controller to add hypermedia links. Then we'll export and import our changes following modular structure. And then we'll test our response as well. Sounds good? Let's get into it. So first thing, go and open up your book controller and we'll be modifying the getBooks function to include links in their response. So there'll be a couple of changes here, okay? And what I will do, I will just paste some code and I'll explain you what we are doing step by step, okay? So I'll just go inside here and I'll paste this and I'll close my terminal, close the folder so you can have the whole screen for you. Now, what I have done here, basically, I define a constant and I call it books with links, okay? Then, all what I'm doing is I'm just mapping through my books, okay? So the books we are getting back from our database. And we are doing books.map. We are using this to iterate through each book in the books array. Every book in our book array, we are creating a new object, okay, that includes the original book data plus additional hyperlinks right there, okay. Now, the book.json is converting the book object, usually a Mongoose document, right, into a plain JavaScript object. And the three dots we are adding before it is the spread operator, which includes all the properties of the book object into our new object. Next thing we want to do is basically add a links array to our book details that we already have, okay? So the links property is added to the new object. It contains an array of hypermedia links which guide the client on possible actions they can perform for each book, okay? Now let's take the first object as an example. So the rel property here is a descriptive name for the link's purpose, like self, for example, for the current resource, or update, or delete, okay? So for example here, we are having self. For the have property is basically the URL to perform the specific action, okay? So for example, this is the one for get call to get a book by ID, if you remember. Now the method, which is the third property, it is basically the HTTP method. It can be get, it can be put, it can be delete to use with this link. Now creating this dynamic link. So the have value use a template literal, as you can see here, with the backticks. So dynamically construct the URL there for us based on the current request. So whatever current request we are building on top of it, this have property right here. Now, there are a few key parts of it. So the first one is the rec.protocol, which gives us the protocol, is it HTTP or HTTPS. Then we have rec.guest host, which gets the host name like localhost 3000 or example.com. And then the other third part is /API/book/book ID, which added the book's unique ID to the endpoint. Now we constructed the new books array with the links. We will go and update this response right here. Okay, and what I will, I'll comment this and I'll add a new one. As you can see, it's almost same as the one we had before, with few things changes. For example, we're still giving back a 200 status to the client so they know that this call was successful. Now, next thing you can see here added is the count property. So the count property helps client understand how many resources are being returned in total. Okay, and we are using the books with links, which is the array that contains all the books with hypermedia links added, and then we're just accessing the length of it to give us the total of the items. Now, next thing is the data attribute, and data attribute hold the actual list of books, including the hypermedia links for each book. It is a clean way to separate the resource content data from other meta information like the count and the links. Then we have the links property, okay? And the purpose for it, this is an additional hypermedia link to guide the client on how to create a new book resource. So again, there are key parts of this one. The rel, which is set to create, which describes the relationship indicating that this is a link can be used to create a new resource. Then we have the have property, which is dynamically generates the URL for creating a new book using the rec.protocol, which again the protocol can be HTTP or HTTPS. Then the rec.get host, and this one is the host name like localhost 3000 or example.com. Then the third part is /API/books, which is the endpoint for creating a new book. In the end, we have the method, which is set to post, specifies that the client should use the post method to interact with this link. Now, time to go and test this. So we'll go to our server, our run my server, so npm start. And then I will just go to my browser, open it up, and I'll say localhost 4000 /API/books. Okay, so my server is still running. I'll let it run. I'll save also my file. There we go. You have added now hypermedia to your API. You can see now we have all the details, how many items we have. So at the moment we only have one item database, so I can confirm that, right? And that is the count. Then our data is updated with the actual details of the book plus the links property, and also we're returning that additional link here to help someone create a new item. Now, adding hypermedia makes your APIs flexible and discoverable as well. Now, the client doesn't need to guess or hard code the routes. They can follow the links you provide. In real-world project, this is an important step towards building RESTful APIs. Now, if you find this video very helpful, hit the like button and consider subscribing for more fun tutorials. Hypermedia might sound complex, but you just implement it step by step like a pro. Next up, we will tackle more advanced API topics in other courses. So stay tuned and catch you in the next one.